Okay, welcome everyone. So today we are going to discuss about a course which is Introduction to Electrical Machine. So in this course we have different kind of devices or different kind of machines which we are going to discuss about them, about their physical feature. That means how they are going to be constructed and their working principles and their performance analysis. So before engaging to the detailed contents of this course, first we need to know two things. The first one is we have to discuss about the prerequisites, and the second one is we have to know about the materials we are going to use for this course. That means the textbooks. So for the first one, that means prerequisites, we have two main prerequisite courses. The first one is fundamental of electrical circuit analysis, and the other one is electromagnetic field or electromagnetic force. So we have to know in detail about these two courses because in fundamental of electrical circuits, the student is expected to know about the basic analytical approach for a given electrical circuit, like circuit theorems, circuit methods, and analytical approaches. So we are going to use those methods, those approaches in this course, in different parts of the course. The other one is we need to know about electromagnetic field courses. We can develop electromagnetic force in a given device, and we need to know about electrostatic field distribution in a given material, and also we have to know electromagnetic field distribution in a given device. And there are some theorems and laws, so we need to know about them, like Biot-Savart's law, Newton's law, Maxwell's equations. So we need to have some understanding about that. So after we say this, so when it comes to the course content, we have 5 chapters in this course. So the first one is magnetic circuits, and the second one is transformers, the third one is induction machine, and the fourth one is DC machines, and the last one is synchronous machines. In general, these electromechanical energy conversion devices are a magnetic circuits, a magnetic devices. They just incorporate electrical circuits, magnetic circuits. So we need to know about those magnetic circuits because energy is converted from electrical energy to mechanical energy, or from mechanical energy to electrical energy on those devices. It may be a motor or it may be a generator. In the case of motor, the electrical energy is going to be converted to mechanical energy, and in the case of generators, this mechanical energy is going to be converted to electrical energy. Or there are other devices like transformers. We can transform, or we can step up some level of electrical energy to a higher level of electrical energy in magnitude. Such kind of energy conversion undergoes in magnetic process. So the energy conversion is from, in the case of motor, from electrical then to magnetic, from magnetic to mechanical. You see, in the case of generator, the mechanical energy first converted to magnetic energy and then converted to electrical energy. So the medium is a magnetic system. So in every electrical machine there is electrical circuits and magnetic circuits and also some mechanical features. So since there is a magnetic system inside those devices, so we need to know how this magnetic circuit operates, how can we calculate, how can we optimize it. So we have to know about magnetic circuits. So in the first chapter we are going to discuss about magnetic field intensity, magnetic field density, and also some basic theories we'll revise from the EMF courses, and then continue with magnetic circuit analysis. And later we will apply those knowledge on transformer and on induction machine, or on the other devices in the preceding. The next chapter is discussing about transformers. So those devices are mostly stationary devices. they have no any rotary part, so they simply change the magnitude of electrical energy from one level to another level. If they may be stepping it up or they may be stepping it down. So without transformer, electrical energy utilization cannot be easy, cannot be feasible. So these devices are very important devices in electrical engineering world. So we will see how transformers are constructed, their principle of operation, and also we can represent these physical devices to an equivalent electrical circuit, and then based on that circuit we can generate some equations. Based on those equations we can control, we can optimize, we can manipulate their performances. So that's why we use transformers everywhere in the grid. There is transformer everywhere in electronic devices as well as in power circuits. The third one is induction machine. These are mostly using AC electrical inputs. This AC electrical energy is going to be converted to mechanical energy. Mostly we are going to discuss about induction motors because almost 90% of motors in every industry is an induction motor. So we are going to see how they are constructed, what are the main components of these induction motors and their working principles, and also their performances, and how can we control their operation. We'll see in detail in this chapter, but they are using AC electrical energy. And also there are some discussions or some contents about induction generators. The fourth one is DC machine. As the name indicates here, that they are using a DC electrical inputs. So they use DC electrical inputs and they convert it to a magnetic energy and then to a mechanical energy. So in this case, we are discussing about DC motors. And in other hand, we can use some mechanical energy converted to magnetic and then to DC electrical energy output. In this case we can say DC generator. So the same as earlier, we can discuss their construction. So we can discuss each components, each parts in their construction, and then we are going to discuss the principle of operations, and then we develop some equivalent circuit which exactly represents the behavior and characteristics of the device. And after we have that equivalent circuit, then we can have an equation which incorporates the inputs and output characteristics, the input output parameters in the equation. Then we can have further analysis, performance analysis, like voltage regulations and terminal characteristics, different, and their efficiencies also can be calculated easily. Then we can talk about how to control them, how to use them efficiently. So the last one is synchronous machines. On these machines, we can say that AC and DC electrical source is utilized here in this machine. So we have to synchronize those energies, and we can have synchronous motors as well as synchronous generators. Mostly we use synchronous generators for electric power generations. So we have two devices like the other earlier mentioned devices. We have synchronous motors and synchronous generators. So in this chapter we have, at the same time, we have two different kind of energy sources, electrical energy sources, which is DC source and AC source in a given machine. So we have to deal with their behavior and their synchronization and etc. So we'll see in detail in chapter 5. Here we are going to discuss about their constructions and their components, parts, and their principle of operation, their equivalent circuits, and we are going to develop some equations. Those equations will exactly represent the characteristics of those devices, and then we can discuss about their performances, then how to control their behavior, under different working conditions. These are the main pointers that we are going to discuss throughout this course. Next time we'll start with the first chapter, which is magnetic circuits. So see you in the next video. Thank you.